All right. Can everyone hear me? All right, there we go. Anyway, just a quick introduction. My name is Pere. I work at Snap as a software engineer in our service mesh team, which is a part of our core infrastructure team.
And hi, I'm Jacques. I'm in the infrastructure security team, and we're heavily involved in the mesh effort.
Yep.
So I work a lot with Pere.
Yes. So what I want to talk to today is about our service mesh and how that works. So we'll go over this talk. There'll be some assumptions made about Kubernetes that you might know or not know. So if you get a little bit lost, it's fine. We'll loop it back. But anyway, I wanted to introduce the problem we had at Snapchat when I got there. So we had a monolith problem. It was basically this big mono world of everything in one place. So basically, Snapchat, surprisingly, all ran off of one API as of basically a little over 1 year ago. So we had one app engine project in one region with a few different microservices, you could call them, but at the end of the day, it was the same API that just took different requests. And you had this one big region, and you can see the problem here. Snapchat would go down a lot because if that region in Google went down, so did we. So we wanted to make a concerted effort to move towards a service mesh. So what's a service mesh? It's kind of like a way to easily develop microservices. So one of the worst parts about a microservice, right, if you've ever built one, you're like, how do I authenticate to everyone? How do I route to people? Like, man, I got to provision a load balancer, and then your service dependency changes their load balancer and breaks you, and that's what the service mesh is trying to solve. It's a way to model dependencies. And so we got into this mono world. So what does a snap mesh solve? So basically we had a big ad hoc thing. So we had App Engine, but we also had people that decided they hated App Engine and built their own thing. We had deployment things all over the place. We had Jenkins. We had people's laptops. That's not my favorite one. We had basically regionalization, and security was kind of retrofitted and hard to figure out. And the authentication thing, there was many different ways people thought you could authenticate a service. Most of them were probably not approved by Jacques here. So how could we solve this? So that's where the mesh comes in, because the mesh allows us to standardize and design the system holistically and kind of force people into this world that is safe and secure. So where does the security team fit in here? So I'll have Jacques talk about that.
Right, so like you alluded to, it's there's been a lot of work to retrofit security, and so our goals actually in getting involved with the service mesh was to take whatever we've been trying to do, but actually make it standard and default, like zero trust network to make lateral movement harder. I've been personally leading crusade to get long-term credentials, so we got rid of that also for Spinnaker and for most of the mesh. And overall, defragment the production infrastructure. That's on all aspects, so it's easier to defend. And Spinnaker, for us, it really helps because it helps us provide this paved road like Netflix advocates, where it's here's a standard way to deploy to a standard runtime. You use that, your life is really easy and easier for us too. You can do something else, but then it's more complicated. So we are heavily involved from the beginning to make sure this whole path is as secure as possible and as easy as possible.
So now I'm going to get into a quick little thing. So give you a nice architectural diagram. It might be a little bit too much if you're not familiar with Kubernetes or Envoy, but I thought it'd be cool to throw it in there. You can always download the slides later and reference them. So this is the first time we've, I think, ever presented this to a public audience. So this is Snap Service Mesh. So what's going on here? I'll try to simplify it as much as possible. So external traffic, as you can see, that's the app or you making a snap. It goes into these two different Envoy fleets, API gateway, ingress gateway. They're both used for different things. API gateway is what basically your application, your phone would connect to. Ingress gateway is how we go cross cloud. So when you go over the link, it goes through a private link to the ingress gateway. Your services are all deployed in a common sidecar pattern in Kubernetes. So Envoy is a sidecar. Envoy is just a proxy. Think of it as a proxy or Nginx. You can also build a mesh with Nginx, technically. And then we have some stuff that's built at Snap. So a lot of you probably are familiar or heard about Istio. It's kind of similar to that, but it predates Istio. It's similar in a lot of ways, but we have a lot of features Istio doesn't have. that we needed with respect to like multi-cloud, and like our circuit breaker pattern had some specific needs and authentication needs. So that's what we built. The control plane's built in the house. It's an Envoy XCS server if you're into Envoy. Switchboard is a front-end UI that we have our developers interact with. So that's how a service owner like declares their service dependencies with like a nice UI, so that way they don't have to like mess up like their configs. And where Spinnaker fit in, Spinnaker deploys your service. So Spinnaker is able to deploy into the service mesh, which at the end of the day is a collection of Kubernetes clusters. So that's kind of how it looks. And we'll get into like what this looks like a little bit more later. So one thing I get a lot, and it was a big problem in the beginning of this project, is that Snap has no way to say you must use something. So this is a question I got quite a lot in the organization, and it was always over and over again. It was like, why didn't you use Jenkins or blah, blah, blah. So here's kind of like where Spinnaker is unique, I believe. So we had to sell this vision of a deployment tool that we could standardize around, and everyone has stuff everywhere. So like they might be on the mesh, but they still got that App Engine service, or they still got a VM they got to deploy to. And Spinnaker is really the only thing I could think of that, or find, that really had a way to integrate all these things together, because there's cloud buy-in from all this. We also had all these, like, and that goes into like deployment scripts. People had these weird logics that they didn't want to keep, but they were good with using some standardized stuff in the future. So we had to give them a way to like migrate without them just being like hard migration, because we had some dangerous deployments we had to do very early on. And then like people just didn't know about Kubernetes really. They're like, what is this? Like, I don't see a UI. You're like, well, there's a CLI, and then you have to figure out what a deployment kind is, and like why your thing is pod loop back, crash back off, and everyone was like, what is this stuff? And they don't even know it's crashing. So Spinnaker allows us to like give people a way to visualize and roll out their deployments, and have it's like an easy way so you can kind of like understand what's going on in your system, and you get good alerts, and like you kind of know what's going on, and you get this one sort of purview of your system and your application, and seeing like it all in one place is a very valuable tool. I was actually very surprised about this. Like I used to talk with Eric and Maggie at Google, and I was like, I don't ever use the infrastructure tab. Our big teams are like, we never use it. But then actually all of our new teams really loved it. They sit in there all day like looking at their deployment and trying to figure out what's going on. I was very surprised about this feedback when I went to my customers, and I was like, because I never use it. So I was like, oh, cool. So it's a pretty cool feature. So it sounds like, wow, this is going to be a great thing. It's just going to work, and everything's going to be great. Well, it didn't really quite work like that. So I'll get into like some of the bad sides first. So when we started the project, there was a lot of features that we just didn't quite have, or weren't quite there yet. So at Snap, we used Graphite. We didn't use any of the supported Kayenta things. And then one of our first customers, their big hard requirement is that they wanted a canary system, and they needed it like immediately. So we had to build Graphite support. So we at Snap actually built that and open sourced it. And we also open sourced some other things around Kayenta I won't get into. But just like tweaks here and there, and adding offsets and stuff like that. So Cloud Driver the Kubernetes provider was in V1 when we started this, and V2 was just starting to be rolled out by Google. And it just had a little bit, it wasn't quite the feature parity yet, let's just say that. So there was a lot of weird little things gremlins that would pop up. And Cloud Driver didn't dynamic onboard accounts, which was kind of a bummer, but we kind of worked through it for a few months. Now, of course, like there's a nice talk from Scott about this. This all works now, and we'll talk about how we use it later. And Halyard just didn't have a way to deploy the Kubernetes kinds that we needed. So we need to be able to use affinities and sidecars, and Halyard didn't technically support it. So that was something that was added in conjunction with Google. So we had some more open questions, like how are we going to handle like the multi-cloud? So Spinnaker has to deploy across 2 different clouds, maybe even 3, maybe even like a data center in the future. If we acquire a company, we have to have something that will go anywhere, and Spinnaker is great for that, but we weren't sure how to do it. Fiat, I couldn't find anyone using it online, so I wasn't sure if anyone was using it in any sort of scale, but we needed it because we needed to have a way to secure the applications. There wasn't a great amount of documentation at the time around operational tasks, like what was going to happen if things went wrong, or how would you resolve them, or what post-mortems from people that said, like, this is the thing you need to do. There's a lot of information on the community about that now. And like Spinnaker assumed a world where you're on a very secured VM with security groups. So static credentials are all over the place. Wasn't great. I was telling that to Jacques was not an easy one. I was like, hey, we just put the JSON for like the root credentials of all Snapchat in a JSON file. It's totally going to work. So scaling challenges. We had quite a few of them. Redis was our main one. There's probably plenty of people in this audience that have been bitten by Redis before. So Redis has just always been a problem child for me. Like it works really great until it doesn't, and you abuse it, and CloudDriver was kind of abusing it. Once you get to a certain amount of scale and like cloud resources, it's very hard to scale it. You have to like start doing all kinds of crazy workarounds. Fiat just crashed all the time in the beginning. It still kind of is very slow. That's something that we've all, as Snap, really interested in fixing in the future. And then CloudDriver deserves its own slide. So if you can scale CloudDriver, you can scale anything. It's like riding a bike. So CloudDriver has a lot of different use cases, and it's very poor to lump it in. It's the opposite of a microservice. It does everything. It's caching. It's doing offline jobs. It's serving a UI. You have to be very careful about it, and it's very, very bad to put it into one instance. You need to split it by workloads. Luckily, Halyard provides a very nice way to do this that we'll get into in a minute. But we had a very, very bad outages that are very, very hard to mitigate when we had even a lot of CloudDriver pods, because if there's a bug in, for instance, serving the UI, you could take out caching, or no one could deploy anymore because now CloudDriver is in a stuck bad state. And you want to avoid that, so you want to keep the failure domains into like a nice window. So that way, yeah, if the infrastructure tab is broken, it's kind of bad, but like no one's going to be blocked. They can still deploy. They can still like look at what's going on. The cloud, but if you can't deploy, that's really, really, really bad. And the cache can be really bad because some providers rely on the cache to deploy. So it's a very bad dependency to take. So we had to go back to the drawing board. So I was like, how in the world are we going to scale this thing? We had 30 Kubernetes clusters. It was using a ton of heap. And we were trying to figure out, we hit the limits of memstore on Google Cloud. Like we couldn't do it anymore. So what did we do? Luckily, Netflix also ran into similar problems. So they started moving everything to MySQL. So I was like, hooray, we have a database now. So one thing I'd like to put there is always is Redis is not a database. It has things that can make it a database, but you probably don't want to use it as a database. It's meant for shared memory. There's some very good use cases for it. I'll get into in a minute that we still use it for. So like durability of execution history. We had a great outage in our first month where Redis flushed and everyone lost their pipelines. Not a great experience for the user. Try to move Orca to CloudDriver immediately. Orca to MySQL, and then CloudDriver to MySQL if you're having scale issues. Splitting CloudDriver and CloudDriver HA is not hard. You should just do it. It's not, there's a Halyard command I think just natively does it now. And we'll get into that architecture in a minute. And then one thing we also did is like each of the services, you got to treat them as their own thing. So you need to use purpose-built node pools for all these. So what's that mean? So like just different instance types, right? It makes sense, right? Some of these things don't use hardly any resources. CloudDriver needs a whole bunch. You don't want to have to scale up your whole thing with 100 gigabyte nodes because CloudDriver is having an issue, and then Echo's sitting there on this big node doing nothing all day. So it's very important to try and design the node pool or design the node you're deploying to for the use case. And then, yeah, like the static credentials everywhere, we kind of had to get rid of that before I got the like keys to the kingdom at Snapchat. And we'll get into that in a minute, how we did that. So yeah, this is a weird trick here that can eliminate static credentials. This is what we did. It's very exciting. So we use Sidecars. So Sidecars are just, at the end of the day, a Docker container running together with a shared sort of mount together. They're all running. It's just the same as if you ran Docker run 4 times and you mounted the shared directory. So what does that allow us to do? So that allows us to have other processes, or basically behaving as a daemon, to do other things for us that helps Spinnaker out without modifying the application. That's the joy of it. So we have these different things here. I'll go over them quickly what they are. Quack is an internal thing that me and security built. It just takes an OpenID token and exchanges a GCP account for an AWS account every 30 minutes or something. So that it basically rotates the credential into the shared directory. So like your SDKs that Spinnaker uses relies on these known directories, for better or worse. So it says like home AWS credentials, that's where my credentials are. So if you just rotate credentials into that mount and you share it with a Docker container, you can just mount it and you could pull it from whatever source you guys use for credentials. Envoy. So this is how we kind of got integrated with the service mesh. I was like, these guys sat next to me in Seattle, and I was like, that sounds great. I want to add off service and service off, and this thing doesn't know how to do it. And like, well, we can just like figure out a way to make Envoy work. So Envoy allows us to essentially proxy requests out of Spinnaker into Snap's infrastructure and use like a well-defined JWT token. So we don't have to build it into CloudDriver. CloudDriver knows nothing about it. It just talks on localhost and like sends stuff out, and it gets to the right, like Jenkins cluster, for instance, or Graphite. And that allows us to use the proper stuff. And monitoring daemon is what is always deployed as a sidecar. We just use Prometheus internally, and we're working on another thing that internally to ship these to Graphite as well. And the great thing is Halyard supports all these now natively, so you can just define sidecars, you can define host aliases, mounts, if you're into that. So it's quite first-class citizen. And this is great because we actually have no static credentials for the cloud. Everything is rotated by our cloud provider on GCP side, and the Quack sidecar is just constantly rotating in new AWS keys. So yeah, so now Jacques was happy. He was like, we can start going to prod, but there was more stuff that we'll have him get into.
Yeah, so essentially when I'm not working on my projects, I'm talking with him. There's been a lot of time on Spinnaker. So yeah. So the direct access to, so essentially what he was explaining is one of the key things we've done is remove all the direct credentials and make sure that we only use instance credentials, so our deployment is homed in GCP and strictly federates into AWS. That federation path, actually, we've contributed fixes on the AWS side, and oh, cool. And so essentially, like, we've been pushing for that for a long time, and like with the sidecars, we're able to use that without changing how Spinnaker works, but we now bolted it to the ground. Like, there's no credentials that are worth stealing because they're all ephemeral. We had to build perimeter security also to limit the impact of some privilege escalation problems that happens with every software. So there's some we mentioned later. And so for that, we put IAP, which is essentially the authenticating proxy from GCP in front of Spinnaker. And we had to do some, and Pere deserves the credit, but there's some work there to essentially merge deck and gate as like one domain, because you have to do that to make it work behind IAP. Feel free to come to us later. We love to talk about those things. And another thing we found out when we started more like pen testing is gate should be a choke point that's like part of the design. And changing from VM to Kubernetes deployment, which is a big shift essentially in how Spinnaker is deployed these days, made it so that this is not enforced by default. So we added like a network policy to make sure that in the unlikely case there's a problem with deck, well, it still can only talk to gate as opposed to talk to all the internal services. And yeah, Fiat took some time to figure out, and we're still not sure we fully figured it out. And so that's something we'd love to discuss later. So yeah, so I was saying, like, we spent quite some time essentially looking also at paths for privilege escalation to not like dismiss insider threat. And as I was saying, so gate as a choke point is something that has to be enforced. Probably the most scary finding was you need to use the whitelist for webhooks. You need it especially in a hosted VM environment, because that can potentially get to instance metadata. So again, as long as you got perimeter security, that's just an insider problem. But you might still want to mitigate that, make sure you got this one checked. Fiat also has semantics that historically meant if you can view a pipeline, then you can execute it, you can trigger it. And now there's the execute permission, which is great. But for backwards compatibility, read means execute by default, so you do want to change that and make read mean only read, if you can afford that. And one thing that was of concern for us for quite some time was spell and like what it could do. So in terms of, so spell is the pipeline expression language, and you can essentially, the Spring expression language, and you can use that to generate pipelines dynamically. It's not that scary in terms of an embedded language. What's still potentially scary, depending how you operate, is that it can pull dynamically pipeline configurations from arbitrary endpoints, but the webhook restrictions can also lock that down. So again, you probably want to use that. And for pipeline triggers, we rely heavily on PubSub. And back to things we're not sure how to mitigate yet with Fiat is making sure that the trigger we receive is actually a legitimate trigger. Like, we don't really have a way to hook that into a Spinnaker. So the best we can do is to do very tight access control on the pub sub topics to make sure only authorized parties can trigger our pipelines. And yeah, I'd love to talk more about that later.
All right, so I'm going to get into a little bit about what our setup looks like now. So I'll get into some detail. We'll show you the beginnings of where we started and then what we did to mitigate these issues. So we kind of referenced the problem of Redis in the beginning. So this is kind of like where our V1 prod cluster looked like. If you're not familiar with what all these microservice names mean yet, or you're new to Spinnaker, I'll go over it a little bit. It's not super important in this slide. So in general, like Orca Cloud Driver Fiat, they used Redis, shared memstore Redis, and Fiat used our Google Groups, which is a great integration because now all of our Gmail accounts now work inside of Spinnaker, which was actually very nice. Echo, we only allowed it to use PubSub, so we kind of came up with our own PubSub topic format that translated into artifacts. There's the proxy trick we talked about earlier. So that also, the nice thing about that is it kind of choke points that one place. So all the people come through IIP, which is very secure, then it hits a hot proxy. So we know that you can't just get right into like the port of gate directly. It allows us to add some logging and metrics as well. Igor, which is like what interacts with Jenkins, essentially is probably what most people use it for. We still had people on Jenkins for things, or they want to trigger like an integration test. It's very useful for that. And the front 50 is basically just where it stores all the configs. So that's stored in Google Cloud Storage. So this is our initial solution. So you can see the problem here. We had a single point of failure in Redis that was pretty bad. That was the one that bit us multiple times. And also the cloud drivers were all in one big cloud driver pod. They weren't split by service type yet. So then where did we go from here? So this is the more salient slide. So this is where we are today. So it's a lot going on here, so I'll take some more time on this slide to explain what's going on here. So the top level is, so you can see these multiple different Kubernetes node pools represented by these dashed lines and like the Kubernetes logo. So each of these represent a node pool that has a certain permission, or they have a certain instance type they're using. So I'll go over what all these mean. So the cloud driver node pool is the most privileged node pool. This is the one that has a service account that can get into AWS, Google, wherever. And it's very, very dangerous and needs the most memory, the most CPU, and all that goodness there. So all of these pods are split by anti-affinity. So that means they all reject each other. I find that in general, all the services would prefer to be one on one instance because there's a whole lot of weird things that can go on sometimes in Kubernetes with scheduling. So I would recommend using anti-affinities. You can look it up online, but you can use all the service selectors to say like reject all other cloud driver pods on this node and then make a tolerance to say only cloud driver can come here. So that's what we did with the cloud driver thing. As you can see, there's a MySQL, so we split MySQL into two of them. The cloud driver one is the latest one because that's the biggest one that allowed us to deprecate the Redis cache. As you can see, Redis is still here though, and I'll get into what that means. So there's a kind of bug with Cloud SQL that doesn't work with the driver it uses doesn't work with Cloud SQL. But it's fine because the Redis scheduler is actually pretty good for what Redis is meant for. So the caching agents in Cloud Driver, they all go to Redis and say, I'm going to start caching something, please take a lock, and then they do work and then put it into MySQL, which is Redis is really good at. It doesn't matter if it goes down, they'll just pick up its work again. Orca still uses it too, the schedule task, because it's a very good queue. But it has its own MySQL, which is important. So splitting these two is good because we have backups of both of them. Like, we don't really need the backup. Maybe the cloud driver one, it could probably rebuild itself. But the Orca one's very important. Make sure you have it in MySQL. Make sure it has backups if you're going to go to prod. It's very important. The privileged node pool over here is similar to the cloud driver one. It has more privileged credentials. So these credentials can talk inside of the Snapchat infrastructure using the sidecar we talked about, but it doesn't necessarily have deployment permissions. But it can like talk to Jenkins and do things and vend tokens and stuff like that. Then we didn't change anything on Echo or Front 50. Those stayed the same, luckily. And then one thing we also did here is we have a public node pool. This is the one that has a service account that literally can't do anything. If you got onto the pod here, you wouldn't be able to do much other than maybe curl gate a little bit. And then this one also has a network, Calico network policy associated with it that blocks them from talking to anything but what it's supposed to talk to. So HA proxy can only talk to gate and deck directly. Gate and deck can't talk to anything else except for where it's supposed to talk to. Deck can't talk to anything at all. So if you got into the deck pod, you couldn't even do anything. And that allows us to like keep the security model inside the cluster a lot better because we have this choke point now. And then the off node pool is a special one. It has a different scope that allows it to talk to G Suite. There's a special OAuth scope in Google Cloud you can give to talk to G Suite. And it has its own service account that has no cloud permissions, but it has very privileged permissions on G Suite to pool Google groups. And that's kind of the overall architecture we have here. So this gives us a lot better of a failure domain than we had before. So now that like CloudDriver kind of keeps to itself, there is still a Redis there that could go down, but it's used so sparsely now that I'm not too worried about it because at the end of the day, it's a very low QPS now. It's just scheduling jobs. And Orca has backups in MySQL, which is the only way to deploy it in my opinion. So this is a much better architecture. Now, also if like for instance, we have a lot of users log on and then RODEC gets overloaded, it won't take down like the deployments. They still run. Like maybe like the infrastructure tab's broken, but users don't notice the problem and then they usually reboot. This hasn't happened in a very long time, but since we've done a lot of fixes have gone into Spinnaker that made this work a whole heck of a lot better. So then like we have all this thing deployed out. It's pretty stable. What do we do next here? So this is where it gets more interesting. This is how we're integrating things in better with the service mesh. So here's a little quick slide we'll go over about like the services that surround Spinnaker. So users represent like a developer at Snapchat. They come into the switchboard, which is the user interface that we integrate with the service mesh. So this is like where all our users, our developers will talk to, or that's what they feel the service mesh is. They talk to this thing, and this is what they associate it with. Under the hood, Switchboard has a bunch of sort of helper services that live in the mesh as well that it talks to. One of them is a cloud provisioning service called Hatchery. So what Hatchery does is essentially apply like Terraform and CloudFormation templates to bring up new GCP or new AWS Kubernetes clusters, do like cluster operations for the user, like upgrading node pools, adding new node pools, and then deleting clusters, that sort of stuff. So that way the user no longer interacts with the cloud directly. This allows us to control what the naming scheme of clusters are, control what the auth scheme of the clusters are. We can install our own roles inside of the Kubernetes RBAC, and that allows a lot of different integrations now, and one of those is Convoy. So Convoy is a service I built at Snap. It's a Spinnaker automation thing that sits on top of Spinnaker. At the end of the day, it's pretty simple. So the problem we had is that we have all these services in the mesh. They all have this like Snapchat authentication scheme. We have to convert that into the IIP authentication scheme. It's actually quite heavy to do that handshake on all the requests, and of course it doesn't integrate with the mesh because it has to do this like OAuth rigmarole. So what we did is like we kind of have Convoy sitting there as a choke point that integrates with our ACL system inside of Snapchat. So we have our own internal ACL system, and this allows us to do a bunch of interesting things around like, does this service count have this access? Can it access this pipeline, or can it trigger this pipeline? Going back to the pipeline integrity. So we choke all of the triggers actually as a webhook now to Convoy. And we can check, like verify the token it's coming from within Snapchat's infrastructure and it's valid, and validate that that service owner has granted that permission to that service account. So like they've added it to this internal ACL list. This enables us to like validate triggers a lot better and choke it in the one spot so we have a full sort of view of what's going on. It makes it a lot easier for us to manage like triggers and how people are using their pipeline. One thing not pictured here is that we also vend like an internal simple Golang CLI that abstracts away some of the stuff. We actually have a few teams using Spin CLI. I'd highly recommend it if you're automating things. There's a lot of teams that actually use Spin CLI in scripts. to automate their pipeline creation or updates. But we'll get into like how we see about updating pipelines in the mesh in just a minute here. So how do Snap developers provision a new Kubernetes cluster? So this is like something that we've spent a lot of time on. Like, it was very hard because people would provision a cluster in the beginning and it would just be like all kinds of messed up. They would do stuff wrong, they would put it in like the wrong security group, and then Jacques' tool would have to go and like find the bad open network policy or the bad open firewall rule, and they would put it in the wrong role and lock themselves out of the cluster. I can't tell you how many times I've actually had to use Spinnaker's super role to bring a cluster back to life for people that locked themselves out. It's pretty easy to do if you edit the RBAC roles and then lock everyone out by accident. Luckily, Spinnaker has a role that can get into it. So we thought about this. How would we have a user provision a cluster? And it made sense to put it inside of the UI that users use to interact with their service. So I'll give a quick, so you animate GIFs, so we'll see how this works. So here's the switchboard UI. This is kind of where service owners interact with their service. It's a looping GIF, so you don't have to follow it the first time. So this is kind of how users create a new Kubernetes cluster. As you can see here, so what's the salient pieces here? So it just basically allows them to choose all the same things they might choose inside the AWS or GCP CLI. But what's happening here on the back end is like once it gets provisioned, there's a lot of things that happen on the back end here. So you can see the service mesh. That's actually our staging service mesh. So you can see the dependency graph of what's going on in the whole mesh, which is an interesting UI. So what's happening on the back end here? So when we provision the things and we choke people in one point, there's many different ways you could do this as like an owner of your infrastructure. You could choke people with like a certain type of like Terraform script, and you could add some automations around that. You could use like deployment manager on GCP, whatever you want to use. But what this allows is that the cluster metadata is now stored with the service metadata. So now we know like who owns this cluster now. We have a Google group associated with. We know a Jira project. We know alerting key. There's a lot of things that we can integrate now. We also know the cluster is going to be auto-upgraded because it's part of our managed clusters now. And we know that Spinnaker has its RBAC roles installed in the cluster by default, so that way we're ready to go to deploy to it. So basically what would happen after this is you would just wait for about 10, 20 minutes for the cloud provider to spin it up, and then you'll see a green little dot. And that's when you can start provisioning a deployable cluster. So that's what we'll get into next is like, how do Snap developers deploy to this new cluster? So now this cluster shows up in your services view. You know, you've made your service dependency thing. So you've asked your service dependencies, hey, please grant this lease. And then they'll say like, yeah, cool, you can talk to me now, you're ready to go. And now that means under the hood, Envoy has the routing tables associated, installed automatically in your service, and also all the authentication keys are whitelisted now. So that means you can authenticate back and forth, and well, it's unidirectional, bidirectional, it could go either way, and you're ready to go. So you're like, all right, cool, we've set up everything, my metadata for my service is all ready to go. How do I then deploy to it? So that's where Spinnaker comes in. So what it would look like today is that the service owner can go into their system. So here's our example service. So they have a cluster here, which is basically just a logical grouping of accounts. So here's sort of a UI we built on top of Spinnaker. So you can select all your clusters you're doing here. You can select like what composition of options you want in your pipeline. So you can like say, I want a canary, I want a zonal rollout, and like health checks. We'll get into like what that means in just a minute. But there's a lot of stuff going on in this UI, but the salient piece for Spinnaker is like, so there's 3 different things you can do. You can look up pipelines. So we're going to start integrating Spinnaker's like status into here too. So like you can go into like a service owner's page and be like, did their deployment fail? Like, can an SRE go in here and like deploy this application if they need to? If there's like a mitigating issue, can us as an infrastructure team know what's going on with all of our applications? That's kind of where we want to go with it. But for now, we just provision pipelines, and we provision, and you can like update pipelines. So what's happening under the hood is Convoy has a list of, just in Golang, it's just like a Go templates of all these different stages, and then it just kind of like loops through them. You could maybe accomplish something similar with managed pipeline v2, but we originally did it this way in Golang just because we had a whole bunch of loops and stuff and spell and loops and all this other madness. I didn't feel too comfortable making all that work, but there's a lot of better things on the horizon, I think, for making this work better. But also another thing you can do here is trigger. I didn't quite get into that, so that'll allow you to like trigger a pipeline if you're like what I talked about earlier, if like SREs, or like, oh, we need to trigger the rollback of this thing. You could technically trigger it through here, and then that will hit the Convoy service, and Convoy will vend a new pub sub token. Where we're also going with this in the future is that the triggering, we want to get to the point where our developers just need to know a image. So like once they have their app, we should be able to deploy it on the mesh. And that's where we're going to keep working these integrations like more deeply and try to improve upon them in the future. So then after hitting save, what does it look like in Spinnaker? So this is what it would kind of look like. So this is like a Spinnaker install. It's our actual prod Spinnaker. So you would like, there's the cluster we've provisioned that's already there. And there's all your checks. So basically what's happened under the hood is Convoy just composes all these steps. It says, hey, I can query your metadata. I know you're in ABC and US Central 1, and you're in BCD and like AP Southeast 1. Like it knows like the regions and the zones that your node pools are in because it deployed them. So that's an interesting integration because it knows exactly which deployment selectors and which node selectors it needs to use to vend your deployment. This allows us to, in the future, this will just all be and hopefully in the world of managed delivery, this will just be me applying this thing, and it will just go out. The cool thing about this is like we've used a lot of the mesh integrations here, right? So we know the cluster name. The cool thing about that is Convoy will put this into GitHub and use the Spring Cloud config thing, which is a new feature that I think Frederick is talking about tomorrow. This allows us to actually onboard things automatically. So it only takes about 8 minutes for a new Kubernetes cluster to show up in our prod Spinnaker now, which is faster than usually people know that it's available inside a switchboard, so it's essentially instantaneous. New clusters show up in 8 minutes. And that allows us to like know how to like just, naming scheme is everything in computers. So if you have the naming scheme down, you can do everything. So that's the important part here, is that you know what the metrics are named, you know what the cluster is named, you know who owns them, you know where they should be going, and you know how to deploy it. And that's it. And we're going to continue kind of working on this over the next year and making it even more away from the user so they don't even have to know how this works. So that gets into a few future improvements that I've just started talking about a little bit. And I'll let Jacques go about the access control stuff.
Yeah, so it's just, so the Convoy that you saw, all that automation of pipeline creation, pipeline triggering, it's awesome what it does. And it's also terrifying from my perspective because to make it work, essentially we got two choices. Either because we use Google Groups, like we're on GCP, so we use Google Group for everything. And typically like teams use their own Google Groups to, like the team internal group, to put on the cluster. And so now, if we want this robot to access Spinnaker, we got two choices. Either that robot can read the internal mail of every team, or that robot comes, and currently that's what happens, comes as full admin on Spinnaker, which means now that robot, because we told you like we're consolidating everything on Spinnaker, so there's more than the mesh. So now that robot, I would like it to only touch the mesh if possible. And so we feel okay with the posture right now, but it's something that we would like to make better. And a related thing is for the webhook stages or for trigger validations, like it seems like right now we're not able to express really the kind of security checks that we would like to get out of the system. So I started discussing that a bunch on the security SIG. We got to kind of like a list of like irritating problems. And I'd love to discuss that more with whoever's interested. Like we're trying to see if we can do a get together at some point during the summit to see like what makes sense as a community to make this a little bit better. Like the analogy I use is maybe give Spinnaker kind of like the SE Linux but light treatment. I mean, we don't necessarily need to involve the NSA or to go like that in depth, but get a good idea of the surface that we want to cover. And maybe that fits with the plug initiative, like make the enforcement pluggable. where definitely the first candidate is Fiat. There's no question about it. But then it's like, is Fiat the one that can grow to capture everything? Or do we need to remeld? It's a conversation I would love to have whoever come find me. Or find Armory and find me, like we're really looking at it.
Yeah. And one of the biggest problems, actually, it's an interesting use case. I don't know if anyone solved it here or dealt with it. So we're building like our own internal infrastructure team. When you're on the cloud, right, you have like a cloud engineer or someone is like provisioning things for you under the hood, right? They're upgrading your maybe Kubernetes master or the control plane below which your container is scheduled on. And since we are actually as an infrastructure team essentially managing these sidecars and managing these daemon sets we install on people's clusters, we need a good way to actually be able to update these in a safe manner. So that's been a very tough problem to solve. Like, how do we roll out new config updates and test them without taking out like all memories? That would be really bad. So, and how do we manage like upgrading Envoy and not knowing that we haven't broken somebody or detecting it very quickly and rolling back? And that's something that we've been trying to figure out. It's like, it's kind of a weird use case. We're not deploying the actual application, we're deploying the things around the application, and we need a safe way to do that, like with validations and stuff. And I feel like there's something there we could do, and it's been a tough one to figure out. Like, yeah. And what'd you say?
I just want to jump on that one for a second.
Yeah. Okay, sure.
It's like, because one of the things that really sold us on the infrastructure security side was the vision from Envoy, from Matt Klein, which is, you do this thing where you put like a service mesh, and you take back your control of your network. Because like right now, essentially, we have like TLS between all the nodes. We're about to switch on MTLS in most places, and that's beautiful. But the one thing that's really holding us from rolling those nice features out is we're not yet fully able to slow bake those changes and canary them the right way, like one canary box per region per service, let it simmer while the other deployments go for the main app, and eventually change all the sidecars. That's a vexing problem right now.
Yeah, so it's a kind of a toughie. We've still been trying to figure that one out. Like, how do you allow an app to roll forward while you're testing something, and then you don't know what you're testing? It's been a tough one, currently unsolved. So it's something we're trying to figure out next year. But yeah, that kind of concludes the main slides here. I've left some time allotted for questions and stuff because it's kind of a lot of content and people might have specific questions or want a clarifying answer on anything. But yeah. Thank you.
Thank you very much, Pere and Jacques. I also just wanted to confirm everybody that their slides will be available in Spinnaker Summit app later. We'll get them up there, but also these guys are great. They'd love to talk to you. Go find them. So I'm volunteering.
Yeah, I'm always in the Spinnaker Slack, and I think my email is on that slide somewhere. So now I'll get tons of recruiter emails. So I just realized that today when I looked at that slide that I actually logged in with my real account. So that's what happens when you're making slides in the middle of the night. So forewarned, but happy to have anyone here talk to me. So.
Hi, I'm Dilip. I run CD at Salesforce. I was curious about your mesh path. Why did you choose to go down this path instead of just doing STO? Did you evaluate STO and stuff?
Oh, that's a very good question. Do you want to take it or me?
I can give a short version.
Okay.
The very short version is when we looked at STO, it wouldn't go cross-cloud. And that was like deal breaker. Like that's the top level one. Like actually I got pitched to join Snap like over 3 years ago. And the vision was, look, so we're on GCP and we want to do both GCP and AWS. I'm like, guys are crazy, that's awesome, let's do it. And Istio was like essentially a big deal breaker in the middle at that point.
Yeah, there's also a couple other things. So Snap scale is actually quite staggering as far as QPS and like the stuff like that. So the Istio team was even scared of it when we're like, well, we might need like 10 million QPS. They're like, whoa, 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 whoa. We haven't tested anything near that. So that's why we built it internally. There's a bunch of other features. If I had my head of the mesh here, he would probably sit here for an hour talking about all the features that he needed. But that was the main one, is just cross-cloud.
So I do just want to say that the keynote starts in 15 minutes, but happy to keep passing this microphone around. Not that I'm really authorized to change anything, but.
Hi. You talked about auth sidecar,
Mm-hmm.
and mentioned about provide service-to-service auth tokens. Can you just give a little bit
I'll let you
more
take that
into
one.
it?
Sure. So essentially, we got several kinds of authentication. The main one that you see with the sidecar is actually dealing with service to service, where we essentially build our own JWT. It's a little, yeah. There's a few fields that are not exact. Like if we did a second take, we'd probably can clean some fields, but essentially, it's just using on Google. We rely a lot on the service account keys that are auto-rotated, because again, we don't want long-term credentials. And you send just a signed token with claims saying, I claim to be this service, talking to that service. Knock, knock, please let me in. That's the gist of it. And the offsite, that's the authentication we do. And the off-sidecar essentially encapsulate that logic to vend the token and to verify them on the receiving end. Does that address your question? Okay.
No.
Not yet.
No.
It's some of it we probably wouldn't be. Some of it is everything got like written really as fast as reasonably possible, and so not all of it is like ready to be open sourced. Not that we don't want to, and we already have some efforts to open source part of our software as we find the time, also to just do the big rewrite. Yeah.
Okay. Thank you very much, everybody.
All right.
Thank you, Pere
Thank
and
you all.
Jacques.